Good day, everyone. We discussed about deadlock schedulers on our last video. Let's discuss on latches for this particular video. Let's get started. Consider we have a row that is getting updated using an update statement. Update statement will hold an exclusive lock till the update is complete. In the meantime, a select statement on that same row is executed while the update statement is underway. This select statement will be blocked by the update statement as the shared lock by the select statement will be incompatible with the exclusive lock taken by the update statement. With this approach, we will ensure that the transaction consistency is completely maintained. Since we have an exhaustive lock mechanism in SQL Server, we can ensure transaction consistency completely. Now the question arises, if locking can ensure that not more than one transaction can change the data at a time and also ensures that there will be no data reads, why do we need latches? Just to keep in mind, locks helps us maintain the logical consistency of the data, but latches helps us to maintain the physical consistency of the data. Let's discuss further here. Page is an object that is of size 8 KB which resides on disk. When you need a copy of this page in the buffer pool, that is the memory, a photocopy of this page is basically put into a buffer which is also 8 KB and that will be placed in memory. For example, I'm inserting value 5, test on table 1. I take an exclusive lock and then consider this value will be put on page 1000. Now, at the same time, if we are also inserting value 6, test 1 on the same table, and if we don't have a latch concept, then we will basically override the previous value with the new value. With latches, the first insert, whichever is executed, will take an exclusive latch and then change the page physically and put the actual data and also updates the metadata on that particular page. While the other insert will wait for the previous exclusive latch on page 1000 to complete and then takes an exclusive latch and then changes the page exactly because we are talking about only one page, basically changes the page 1000 appropriately after the previous insert is done. Locks are for maintaining the logical consistency, that is, to maintain your database ACID properties. ACID property refers to atomicity, consistency, isolation, and durability. Let's discuss a bit on ACID properties and then we will continue on with the latches. Atomicity. It is either all or none. That is, a transaction that is started will have to either complete to its fullest or none. This is done using an implicit or explicit transaction by SQL Server. Implicit transaction basically means like you run a simple insert or an update or a delete statement. It'll be simple or complex. What happens is like SQL Server implicitly adds an begin and commit or rollback as appropriate. As far as explicit transaction is concerned, we ourselves, the users, basically put in and begin tran and then try to complete all the transactions. And in case everything is fine, we go for a commit tran. And all these things are mentioned manually by the user. We maintain all details on the transaction log using write ahead logging, and we will be able to roll forward or roll back anytime required. Let's move on to consistency. Before and after any transaction, a database must be in consistent state. We enforce this by using constraints, and these constraints cannot be violated. For example, you will have to insert only integer value on an integer column. You cannot have duplicates on a primary key column, and all these things are basically enforced using the constraints that on the database. As far as isolation is concerned, all transactions performed will be isolated from one another. That is, non-committed data of one transaction should not be seen by another transaction on a read committed and a higher isolation model. This is enforced using locking and concurrency strategy. Talking about durability. Durability refers to maintaining changes on the databases even during catastrophe. This is taken care by flushing the dirty pages every now and then, depending on the recovery interval using checkpoint, and by performing undo and redo using transaction log. Let's look at a scenario. So let's consider we have three transactions, T1, T2, and T3. At this point in time, we have checkpoint 1. At this point in time, we have checkpoint 2. And at this point in time, we have checkpoint 3. So if we look at it here, transaction 1 basically completes here. And then we have a checkpoint 2 happening at this point in time. And transaction 2 basically has kind of completed and committed at this point in time, but the last checkpoint is like checkpoint 3, and it has happened here. And now as far as transaction 3 is concerned, it is basically running, and what we can see is like even after checkpoint 3, this transaction has not completed. So that's the reason we have mentioned it here as uncommitted. So let's consider at this point in time, SQL Server restart. So what happens is like when the SQL Server comes online, the SQL Server basically checks like what was the last checkpoint, and after this checkpoint it will check like what are the transaction. And as far as T2 is concerned, since it is committed, what it basically does is like it looks at the transaction log, and then it basically rolls forward all the pages or all the this particular transaction from this point, that is checkpoint 3. Now as far as T3 is concerned, that is your transaction 3, it has not completed, so it is basically like kind of an uncommitted. We have mentioned that is like it has never completed here, so SQL Server restarted. So what it basically does is like it goes to the last checkpoint, which is checkpoint 3, and after this it basically what it does is like it basically like undo all the things that has happened from here to here. So that's what happens as far as the recovery is concerned. Okay, moving on. Let's talk about latches again. What is a latch? Latches are basically a lightweight synchronization primitive, guarantees that consistency of in-memory structures. Latches are internal mechanism by SQL Server, and the user is not going to control it. It is basically controlled by the SQL Server itself. SQL Server determines which latches to use and at what time or at when. What do we take latch on? So IO latches. It basically protects pages that are not yet loaded into the buffer pool. For example, page latch IO sh shared or page latch IO underscore exclusive, which is EX. So we can see page latch IO underscore sh and page latch IO underscore EX as an example. Buffer latches, which are used to protect pages in the buffer pool. For example, page latch underscore sh or page latch underscore ex. We have other things, but we are just discussing about the common things that we can see. Next one would be non-buffer latches. These are the latches that are used to protect pages other than the buffer pool. For example, latch underscore sh or latch underscore ex. So let's discuss about the different types of latches that we have. There are close to like 5 latches, and the first one would be the destroy latch, which is DT. The most restrictive latch mode acquired when a latch is destroyed and a buffer is to be removed from the cache. Exclusive latch acquires exclusive control of a page being written, prevents all other latches to be acquired on the page where EX latch exists. Next one is update latch. It is restrictive, similar to an exclusive latch, with an exception that it allows read operation to access the page, but restricts explicitly any write operation. Shared latch. Acquired on a page when a read request issued to a page is granted. The next one would be keep latch. Keep latch, it serves to preserve a latch order record, but also to ensure that it stays in the buffer when a new latch is being placed on it. Let's discuss about the difference between the locks and latches. Yeah, As far as locks are concerned, the purpose of having a lock is to guarantee consistency of the transaction. And as far as the latches are concerned, the purpose would be to guarantee consistency of in-memory structure. So that's the reason we tell like locks are used for locks are used to maintain the logical consistency, and latches are used for maintaining the physical consistency. And as far as locks are concerned, there is way users will be able to control it. For example, you can do that using different isolation levels, or you can also utilize specific query ins to control which kind of lock is required. But as far as latches is concerned, it is completely controlled by SQL Server, and users have no control over it. As far as performance is concerned, logs are kind of heavyweight because it basically holds this particular log for the duration of the transaction. You start a transaction, you take a log, and then you release that log when you basically complete that transaction. But as far as latches are concerned, it is lightweight and it is held only for the duration of the physical operation. So let's consider you're moving a page onto the buffer, and that is when what you do is like you basically do it per page basis. Like for example, if you need to change that, you basically put in an exclusive latch, modify it, and then you release it. But as far as locks are concerned, it is going to stay there till the transaction is going to complete. So that's the difference between lock and latches. Okay, let's say you have a transaction where you're updating 100 pages that has close to 1,000 rows. So what we are basically doing is that we're going to update close to 1,000 rows. And if we look at it internally, these 1,000 rows are basically stored in 100 pages. Okay, so when this transaction is happening, you will take logs on all the 100 pages till the transaction is complete. Yeah. On the other hand, you will not latch all the 100 pages at the same time. You will basically be latching only a page at a time when you are modifying it and then immediately release it. For example, if you're going to read it, you basically latch it using a shared latch, and then you will be releasing the latch on that page once once that particular thing is completed. So it is basically it will be held only during the physical operation and not for the whole transaction time as far as latch is concerned. Okay, let's talk about how a worker thread is going to use latch here. Okay, so let's consider worker thread A scans table 1. It requires page 500. So that means like as far as this is concerned, it is going to just read only one page 500, which is page 500. Just for the example, I'm just using one page. It is never going to be one page as far as any transaction is concerned. But just for understanding purpose, I'm going to use only one page. So as a recap, worker thread A scans table 1, and it requires page 500. So let's consider the page is not in the cache. So what will happen is that it will basically take an exclusive latch on that page and then move it to the buffer. An exclusive latch is taken on the page at a time because while the pages are moved to the buffer, no other transaction should basically modify that buffer. Yep. For example, if page 500 is moved to the buffer, no other worker thread should move any other page to this buffer. So that's the reason we take an exclusive latch there. Yep. Once the exclusive latch is taken, we place an asynchronous IO request. After this, page IO latch underscore sh wait happens till the page is moved to the buffer. Till the page IO latch sh is there, this worker will be on the waiter queue. And once the IO completion routine is done and is signaled by another thread, let's consider here, let it be thread Y, as part of the janitor task. And this is when the page is loaded to the buffer. At this time, we release the exclusive latch and then take a shared latch as it has to read now. Yep. I'm pretty sure it will be a little confusing. I'm pretty sure on that. So what I suggest is like you can pause this and hear at least this part couple of times to understand it. That's it for this video. We will speak more about latch contention on our next video. Thanks for watching. Have a great day. Jai Hind.